State Route 54, San Diego, California. November 1992. A backhoe cuts into the earth to widen a highway. The operator is moving fast, pulling cubic yards of sandy soil out of the ground as part of a routine Caltrans expansion project. Then the bucket catches something large. The machine stops. A paleontologist standing nearby walks over, crouches down, and looks at what has just come up. He doesn't call a press conference. He doesn't call a university. He calls his boss. What followed that moment would take 25 years to fully understand, and it still isn't fully understood. To appreciate what was found under State Route 54, you have to understand what science believed about the Americas in 1992. The dominant view, held firmly for decades, was that humans first arrived in North America roughly 13,000 to 15,000 years ago. They came across a land bridge connecting Siberia to Alaska, a stretch of exposed terrain that existed during the last ice age, when sea levels dropped low enough to create a walkable corridor between continents. These early arrivals, known in the archaeological record as the Clovis people, left behind distinctive fluted stone spear points across the continent. Their tools showed up from Montana to New Mexico, from Virginia to Texas. The Clovis first model, as it came to be called, was the established framework, and it had wide support. There were dissenting voices over the years. A site at Monteverde in southern Chile produced evidence of human occupation dating to around 14,500 years ago, which meant people had already pushed to the southern tip of South America by then, suggesting an even earlier arrival in the north. That finding rattled the Clovis consensus without shattering it. What most researchers agreed on, regardless of the debate's margins, was that humans had not been in the Americas before about 20,000 years ago at the absolute earliest. 130,000 years was not a number anyone was debating. Richard Cerruti was a field paleontologist with the San Diego Natural History Museum. His job during the SR-54 expansion was straightforward. Stand on site during active grading, watch what comes out of the ground, and flag anything that looked like a fossil before a truck drove over it. California law required this. Previous highway projects in the San Diego area had turned up an impressive record of prehistoric life, including ancient walruses, camels, and horses. Cerruti was experienced, and he knew what fossil bone looked like from a distance. What he spotted in November 1992 appeared, at first glance, to be a mammoth tusk lying horizontally in the sediment. He called for construction to stop. He contacted Tom Demarais, the director of the museum's Paleo Services Department. The two men began examining the site carefully, using hand tools instead of heavy machinery. Within days, as more material came to light, it became clear the animal was not a mammoth. The teeth were wrong. Fragments of distinctive molars confirmed it was a mastodon, Mammoth americanum, a large browsing animal related to but separate from the mammoth, and one that had roamed the Americas for millions of years before disappearing around 13,000 years ago. The mastodon was interesting. What surrounded it was harder to explain. Clustered around the bones were large cobblestones, some weighing several kilograms. The cobbles were not native to that sediment layer. They had arrived there from somewhere else. Several showed clear patterns of impact and wear on their surfaces, and the mastodon bones, particularly the heavy limb bones, were broken cleanly, in ways that pointed to deliberate force applied while the bone was still fresh. Demarais later described his reaction to the overall site in careful terms. Something about the arrangement did not fit any natural explanation he could immediately place. The large rocks, the bone flakes concentrated around them, and the unusual positioning of the remains. He secured emergency funding from the National Geographic Society in January 1993, and excavations continued through the winter and into the spring. By the time the team finished, they had recovered 2 tusks, 3 molars, 4 vertebrae, 16 ribs, 2 phalanx bones, 2 sesamoids, and over 300 additional bone fragments. They had also recovered 5 cobblestones, displaying impact marks and wear patterns on their surfaces. The bones and the rocks were found in the same sediment layer, which geologists identified as a fine-grained deposit formed in a low-energy environment, not the kind of place where fast-moving water could have jumbled and broken heavy bones on its own. Then there was the question of age. The sediment layer told the team the bones were old, but how old was another matter. In December 1993, Demolished sent samples from the site to Dr. Richard Q, a geologist at USC, for radiometric dating. On December 29th of that year, Q called him with the results. A caliche sample from the Mastodon sediment layer was dated to approximately 190,000 years old. Demolished, by several accounts, was stunned. The result was so far outside accepted parameters for human presence in the Americas that the team knew publishing it would invite immediate rejection. Without corroborating evidence and better dating methods, they held back. The site sat largely quiet through the late 1990s and 2000s. The bones were curated, notes were kept, but the Kiruti Mastodon site was not widely known outside specialist circles, and the mainstream archaeological community had no reason to pay attention to it. The situation changed in 2014. By then, uranium-thorium dating had advanced considerably. This method works by measuring the ratio of uranium-234 decaying into thorium-230 within a sample. For older materials where traditional radiocarbon dating breaks down, it can produce reliable results given the right sample conditions. Demolished sent several mastodon bones to Dr. James Paces, a geologist and geochronologist at the U.S. Geological Survey. The results came back at approximately 130,700 years old, with a margin of error of plus or minus 9,400 years. That date held up across multiple samples. The team now had a number they were confident in, and the number demanded an explanation. Demolished brought in Dr. Steve Holen, Director of Research at the Center for American Paleolithic Research in Hot Springs, South Dakota. Holen had spent years studying mammoth and mastodon bone sites in Nebraska and Kansas, where bones showed similar fracture patterns, and where geological forces and carnivore activity had already been ruled out as causes. When Holen examined the Suruti material, he saw the same signatures, but the California site had something the Nebraska sites lacked: the actual stones that could have produced the damage. Dr. Dan Fisher, a paleontologist and mastodon specialist at the University of Michigan, was also brought in. Fisher had conducted controlled experiments breaking the bones of recently deceased elephants using large hammerstones. The fracture patterns he produced in those experiments, the spiral breaks, the cone flakes radiating outward from impact points, matched what was present on the Suruti mastodon bones. The team's conclusion was that an unknown hominin had used cobblestones as hammers and anvils to break fresh mastodon bone, probably to extract marrow or harvest raw material for tools. The bones were found in two distinct clusters, each centered around a large flat stone. The researchers interpreted those stones as anvils, with the surrounding material representing the debris produced by repeated percussion. In April 2017, the team published their findings in Nature. The paper, authored by Holen, Demolished, Fisher, and several colleagues, described the site as the oldest in situ, well-documented archaeological site in the Americas. The response was immediate and divided. Some researchers found the evidence credible. The dating methodology was sound. The fracture analysis was consistent with known percussion patterns. The sedimentary context was clear and undisturbed. Richard Fullegar, an archaeologist at the University of Wollongong in Australia and one of the paper's co-authors, had studied stone tool use wear for decades and said the wear patterns on the cobbles were consistent with active use as hammerstones. A 2020 follow-up study went further. Researchers, including Fullegar and Demolished, identified bone microresidues on the surfaces of two specific cobbles recovered from the site. The residues were found only on the upward-facing, wear-marked surfaces of the stones, not on their undersides or unworn faces. This asymmetry mattered. If the bone material had simply settled around the rocks through environmental exposure, residue would coat the stones more evenly. The pattern suggested the contact was forceful and directional, consistent with a stone being struck against bone or bone being struck against a stone. The critics did not go quiet. Michael Waters, a prominent archaeologist at Texas A&M University, who has devoted much of his career to studying the first Americans, made the case that the evidence did not meet the standard required for a claim this large. His position, shared by many in the field, was that demonstrating early occupation at that scale requires unequivocal stone artifacts, meaning objects shaped deliberately with clear signs of intentional knapping, not cobbles that could conceivably have been modified by other means. No knapped stone tools were found at the site. No cut marks from butchery appeared on the bones. No human remains of any kind were present. Others raised the possibility that construction equipment had disturbed the site before Cerruti spotted it. A former Caltrans land surveyor suggested the excavator's teeth could have dragged the cobbles into the site from elsewhere and could have fractured the bones in the process. The research team countered this by pointing to the carbonate crusts that had formed over and around both the bones and the stones. Crusts that take thousands of years to develop, and that enclosed the material in place, establishing what Demolished called a chain of evidence, showing the objects had not been rearranged recently. The debate exposed something broader about how science handles claims that challenge deeply embedded frameworks. The Cerruti site did not fit. It had no known context, no comparable site anywhere near it in age, and no human species that science could comfortably place in the Americas at 130,000 years ago. The Neanderthals were in Europe at that time. Homo sapiens had not yet left Africa in significant numbers. Whatever had been at that site, if anything had been there at all, was something the record could not currently identify. That uncertainty is not comfortable for any field, and it was not received comfortably. Richard Cerruti, the man who stopped a construction crew and changed the direction of his museum's next 3 decades, died in 2019. He did not live to see the debate resolved, because it hasn't. The bones and stones from the Cerruti Mastodon site are housed at the San Diego Natural History Museum. Part of the original site remains sealed inside an earthen sound berm along State Route 54, unexcavated, preserved by the same highway infrastructure that uncovered it. Researchers have expressed interest in returning to that section. Tom Demolished continued working at the museum and continued defending the site's findings against criticism, which he acknowledged was expected. His position remained consistent. The evidence, taken as a whole, points toward deliberate human activity, and the absence of flake tools does not mean the absence of people. A site where someone processed bone with cobbles is not the same kind of site as one where someone made spear points. Different activities leave different traces. Whether the scientific community eventually accepts the Cerruti interpretation or finds a natural explanation that accounts for all the evidence remains an open question. What is not open to debate is that something happened at that location 130,000 years ago that is difficult to explain cleanly. The bones were broken in a specific way. The rocks were there. The distribution was not random. State Route 54 carries tens of thousands of cars through San Diego County every day. The drivers passing over that stretch of highway near National City are not thinking about what is buried beneath the asphalt. Most of them have never heard the name Cerruti, but 9 feet below the road surface, sealed in fine-grained sediment and carbonate crust, the question is still sitting there, unanswered, waiting.